So we're going to graph this. You already kind of have a picture in your head about what it might look like. Okay, so I'll just tell you how I do it. I go immediately to my vertical asymptote. Can we tell me what my vertical asymptote? Remember, it's a line, so don't just give me a value. And where did that come from? Okay, right away you knew it. All right, the next thing I look for is, do I have a hole, a horizontal, or a slant? Do you remember from yesterday when I would have a hole? What happens with a hole? Okay, the numerator and denominator cancel. Okay, and there's a line left over. Okay, so does any of this cancel, or am I good to go? No. How do I know the difference then between a horizontal and a slant? So I've gotten rid of hole. I know there isn't a hole because the denominator didn't cancel. How do I tell the difference if I have a horizontal or slant? I have one or the other. What one do I have? What do you think? When the power is bigger in the numerator, I have a slant. So I'm repeating that here. So here. So that's gone. So I have a horizontal. Now, we do this in calculus, a calculus way. Just think about it. As I put a super large number, so x is headed toward positive infinity, if I put a super large number in there and divide, what am I going to get out? 2 over a million is what? If I have $2 and I divide it into a million people, like how much money are you going to get? Close to zero, like not very much at all. Would you agree? So that is a line. Y equals 0. Okay. Yesterday we talked about long division. We have a quiz on it today, so we're going to do this long division. 2 is being divided by x minus 4. This kind of looks weird because there's not much to divide. What times x makes it go away? 0, you bet. 0 times x is 0. 0 times negative 4 is 0, so I have a remainder of 2. So it looks the same, doesn't it? Why would I do that? Let's think about when we had graphs. I'm going to rewrite this just a little bit different look here. You don't have to long divide. You did all this without long dividing, but I just want to show a connection. This is saying move my graph which way? Up, down, or left, right? Up and down because it's not with. So 0 up or 0 down sits me where? On the, close, on the axes because it's a line, yeah. And then who's with x? And so that's going to shift it. So would you agree this would shift it right? And this would shift it up? But it's not going to shift up any. It's a 0 shift. Questions on that? Okay, domain and range. The domain is fairly straightforward to find. I can put any number in there except for who. You kind of already found it, right? So all reals except who? And how did you know it was for? Right, and who does it really match to? The vertical asymptote or the horizontal? Yeah, see, these two play off of each other. We are not going to find range. It's way too much work. Okay, intercepts. So they are ordered pairs. I like to find the y-intercept first. It's much more straightforward. Put 0 in, and what do I get out? And so 2 over negative 4 is negative a half. Now the x-intercept always seems to cause or create some issue because the x-intercept happens when y is 0. When is a fraction equal to 0? There's only one time, and when is that? When is that time that my fraction is equal to 0? When 2 is equal to 0. When the numerator is 0, my fraction is 0. Is that ever going to happen? Nope, so there isn't one. So we're going to sketch a graph. And we made a table when we did polynomials, so we're going to think about making a table. Vertical asymptote is, I'm going to put those in red, x equals 4. Horizontal asymptote, I know a point, only my y-intercept, 0, negative 1/2. I'm claiming that I don't think you really need to make a table here. Would you agree with that? Do you know the left-hand piece of this? The graph follows asymptotes and comes down. The only one you're going to have to check is on the right. It could be above and it could be below. So let's just do a checkpoint. What's a checkpoint I could try to see if I'm above or below? Bless you. What's a checkpoint I could try? I could try 6. So am I going to try 6 in? I'm going to try 6 into my function. If I put 6 in there, is that positive or negative? That's all I care. Is it positive or negative? And so where does that tell me my graph is? And asymptotes are things that you get really close to, but you never intersect. Is that a function? Did I need my table? No. I hardly had to do any computation. Would you agree? Okay, let's try another one. Let's just try a few so you get better at these. And I kind of mix these up. So I'm always jumping to my vertical asymptote. Ooh, what should I do on this? What should I do with x squared minus 4? What does that seem like I could do? Yeah, x plus 2 and x minus 2. So how many vertical asymptotes did I find? You can have many of them. How many did I find? And so what would their equations be? X equals. Okay, good. All right, so now we have to ask this question. Is there a hole? Nope. How come? How did you know there was no hole? Nothing cancels. Good. Horizontal or slant? And why not a slant? Good. So you're looking at the powers, the numerator at a smaller power. Okay, so let's figure out this slant. Sorry, this horizontal. There is no slant. So if I have this, and I put a very large number in for x and square it, what happens to that very large number? It even gets bigger. So what's negative 5 over a very, very, very large number? Okay. Make sure you make it a line. I also know my domain, all reals except for who. Okay, we're not going to worry about range. I just don't think it's worth our time to spend on that. Okay, I always go to my y-intercept next because it seems pretty straightforward. I think it's something I could do without a lot of worry. And what do I get when I plug 0 in? 2 negatives, 5/4. Okay. And then the other one is make y be 0. Will this fraction ever equal 0? You only worry about the numerator. I don't think we need a table. We might, though, have to check some values. So you can use a table, but I think if you look at what you've got, negative 2, positive 2, and 0, and you have 0, 5/4, which is going to be here. Would you agree? Okay, how would I know where to go on these sides? What value could I pick here just to test it? Okay, on this side though, let's go, how about, could I do negative 4? Okay, so, or I could have done 3. So let's see what I've got here. What happens when I put 4 in and square it? So is it going to be a positive number on the bottom or a negative? So a negative divided by a positive. Do you agree your graph would be negative in that section? Okay, let's go to this far section. What happens when I plug in a positive 4? Is it exactly the same? Is it okay? So it's going to be down here. And then what about that middle section? Is it just a dot? Or what do you think it might do? Yeah, how would you know it would go up on both ends? Is that just something you've seen before? Yeah. And you follow asymptotes. Now, asymptotes, people think you'll never ever cross them. That's false. You can sometimes cross them. Not in the long run. That's what we call it long behavior, but in the short. All right, let's plunk out another one here. Vertical asymptote. Do I have a hole? What cancels in my denominator? Ooh, no hole. Slant or horizontal? Okay. And what is my horizontal? If I have a super large number, like 1,000, not very much, over 1,002, and I divide those, what am I kind of getting close to? 1 or 0? If I took x plus 2 and divided by x, would you agree I would have a 1 there? And I would get 2 over, did I do that wrong? Shouldn't this be, can I restart that? No, what goes on the inside? X plus, no, isn't it x is divided by x plus 2? Was I doing that right? I was, wasn't I? So there's my 1. And when I subtract, I get a negative 2 over x plus 2. And so can you see a shift left and a shift up from the form? Okay, so I always go right here because I know it's easy to plug 0 in. When I plug 0 in, what do I get out? Oh, careful. Oh, 2 on top. Yeah, 2 on the bottom, but what's on the top? And what's that fraction equivalent to? So did I already find it when y was 0? If I take this fraction and I set it equal to 0, would you agree x would be 0 as well? You kind of already found it. Okay, let's plot all this stuff. Okay, then let's see, we had, what do we have? Negative 2 is my vertical. We had 1 as my horizontal. And I knew I passed through 0, 0. Do I already know that section of my graph? So what's the only other section I need to test? Can you give me a test value? Remember, this was negative 2, so what's a test value? So I'm going to plug it into my function. And what do I get when I plug it in there? All I care about is it negative or positive. That's all I care. Negative in the numerator. What's in the denominator? Negative 3 minus 2. Is it also negative? What's a negative divided by a negative? So I got a problem. Is it going to be in this section or in that section? What do you think? What is it? Oh, is it plus 2? Sorry. Is it still negative? What kind of number would it be? It would be 3. So would you agree it would be this dot up here? So I could have had my graph be here. That would have been okay. It's still a function. So you have to kind of find the value when you do it that way, if you're not using your table. Good? Okay, let's plunk through just a couple more here. Bless you. Okay. Oh, what do you think you might do on this one? Okay, I would always try to factor. And if I'm going to factor this, x plus 5, x minus 2 over x minus 2, what happens to the x minus 2's? All right, so my whole weird-looking graph turned into a simple what? Yeah, but there's still a problem with that line. Okay, so your homework online actually said you cannot forget, even though that canceled out, still there. So I don't have an asymptote, but I have a problem, and it's called a hole. So what's the x-coordinate of my hole? Yeah, it would have been my vertical asymptote because it canceled out. It's no longer an asymptote. So if x is 2, a hole is an ordered pair. What's the y-coordinate? If I know y, my new look is a line, and I know my x-coordinate, could I find my y-coordinate? Yeah. Okay. So if this is my line, do you know your y-intercept just by looking at it? 5. And maybe Hoxie taught you the cover-up method. If I'm looking for my x-intercept, I cover up y, move the 5 over. What's my x-intercept? Or you could say I put 0 in for y, and I solve for x, and what do you get? So I don't think there's any other asymptotes. I'm graphing a line. Y-intercept is 5. X-intercept is negative 5. 2 points, connect them, have my line, but I have to do what? And where's that hole again? So 2, 7, I would have literally like this open little blank. It would like skip a step. It would skip a step. Oh, I think we have one more. Is that right? I feel like I'm just blazing through this. You guys good? Okay, notice I really didn't do domain and range on the last one. Yeah. What would my domain and range on this one be? I could have every x value except for who? Yeah. It's still this value, isn't it? You actually know your range pretty easily. I could have every value except for what. So, and I don't really care if you find the range. I won't ask you. And notice all these other things, there's nothing to put there. I'm giving you a table if you want to construct it, but if you don't need to, then why, right? What should I do on this one? Okay, what do I get in the numerator? Let's see, both signs are negative. Does it factor? Does that work? Yeah, are you okay that it works? Yeah. Does the x cancel out? So, do I still have a vertical asymptote? And who is it? Didn't cancel out? So now you have to make this decision. Is it horizontal or slant? Okay. And what clued you into that? Exactly. How do I find the slant? Just like I was finding horizontal if I wanted to? Long division. Okay, so you're going to have a long division problem on your quiz today, so let's do one together here and make sure that we've got it. Then we'll practice a couple on the board if we need to. Okay, would you agree that that's my long division? Okay, so what do I do? How would I find this division? What times x is x squared? When I subtract, I bring down the next number. What times x is negative 2x? When I subtract, I bring down the 1. There's no more division to be done. Now, what you have to kind of realize is this entire function is this. It's just a different look. Remember, like we had parabolas and we put them in vertex form, standard form? It's exactly the same. So who's your slant asymptote? So that is your slant. So slant is y equals x minus 2. How else could I, well, we'll look at that later. Okay, we good? Okay, x-intercept and y-intercept. I'm just going to find my y-intercept. When I plug in 0, what do I get? Here, if I get x squared minus 2x plus 1 over x. When I plug in 0 for x, can I even do that? Problem with the bottom. So let's look at my x-intercept. That happens to be when my fraction is equal to 0. Where's my fraction equal to 0 at? Questions on where she got 1. Are you okay with that? It's only your numerator. All right, let's see. We could fill this in all reals except 0. Range is much more difficult to find, so we're not even going to worry about it. It's nothing that we use. I just copy a blank thing and just, so sometimes we need what I have up here and sometimes we don't. I hope that doesn't bother you. 1, 0. We have a vertical asymptote and our slant asymptote. And do you see why we call it a slant asymptote? Because it's what? Because it's slanted. Do you know where one part of your graph is? Agree? How do I find the other part of my graph? Don't just assume you know, because I'll have to you verify it. Where do you think it is? It's either in the x or outside. So you know it's there, but you have to verify it. So what's a checked value I could plug in that's pretty easy? Negative what? So negative 1 squared minus 2 times negative 1 plus 1 over negative 1. I think I'm going to have to do a little bit of work on this. So this is 1, this is 2, and this is 1. Is it a negative value? Now, how big of a negative value is it? It's going to go all the way down to what? 2 plus 1 plus 1 is how much? 4 over negative 1. So here's negative 1. 1, 2, 3, 4. So it's going to be right in there. Do you see why I knew it was in? It could have landed up here, but that's why you have to do a little bit of simplification. Okay. We ran through that awfully quick. You good? Got some hints and tips of what to do? Okay.